the periodic table. I think where we were yesterday was the we were ready for part B, because we're going to skip over part A for right now, for the valence electrons, okay? Because I think that part, it'll be better if we cover that at the beginning of next semester when we start talking about ions and ionic bonding and stuff like that, okay? All right, so we talked about the periodic law the other day. Just for review, if they're in the same column on the periodic table, they're going to have similar properties, right? So tell me something that would have similar properties to magnesium. No. Same group, right? Something that would have same properties as magnesium. Calcium, right? Which one? B. Oh, beryllium. Okay. All right, so beryllium, calcium. Listen up. You guys need to get this. Anything in the same column, all right, as magnesium. So right above magnesium you have beryllium, right below you have calcium, okay? So those would be two that you could guess probably have very similar properties to the magnesium, okay? All right, the valence electrons thing, like I said, we're not going to worry about that for now. So another way of classifying elements besides just the 4 blocks of the table. Now, we need to go back and kind of talk about the 4 blocks for a second, okay? So pull out your blank periodic table that I gave you yesterday also. Let me just do this real quick, okay? So your blank periodic table, it's not going to look exactly like this because it doesn't have any letters in it, okay? But I want to show you a couple of things. And they actually are kind of labeled on here already. And we did talk about this very briefly before when we were talking about electron configurations. But I just want you to label a couple of things on your periodic table that I think is going to help you out with. I broke one more. Okay. So when it refers to the 4 blocks of the table, that's assuming we've already talked about something, and that something is the difference between this block on the periodic table, this block, and this block, okay? There's sort of 4 different blocks on the periodic table, 4 broad categories of stuff on the periodic table. Do you remember what we called these right here? I just mentioned it one day. The ones on the far left here. And it has to do with the orbitals that their outer electrons are going into. Okay, so if I have something like hydrogen, what is its electron configuration? Hydrogen. 1s1, right? Okay, it has 1 electron in the 1s. Now, if we do lithium, its electron configuration would be 1s2, 2s1. Okay, if we did beryllium, it would be 1s2, 2s2. So notice here, all of these, their electron configurations end with the s's. Okay, if I did sodium, it would be 1s2, 2s2, 2p6, 3s1. Okay, again, it ends with an s. Does everybody see that? So all of the atoms whose electron configurations end with s, those are called the s block elements, and they're all right here in this group. Okay, that's called the s block. All right, so if you want to circle that on your blank periodic table and label that as the s block, okay, that's what that's called.
I'm gonna go to the middle ones all in then.
Good guess. Okay, let's talk about the block on the far right first. This block right here, okay? So if you look at any of those elements and you write their electron configurations, with the exception of helium. Helium's a little weird because it's just 1s2, okay? But everything else in this block, like boron, 1s2, 2s2, 2p1. Okay, that's boron's electron configuration because it has 5 electrons in it. Okay, it ends with a p. Okay, so its last electron is in a p orbital. All right, and that's true for all of these in this block over here, so we call that the p block. Okay, the one on the far right, this one right here, that's the p block. Okay, one on the left is the s block. The one on the right is the p block. And again, they're called that because their last electrons will go into an s orbital over here. The last electrons in the element will go in a p orbital over here. Okay, the end of their electron configuration is a p. And then the ones in the middle, right here, these are also called transition metals. We'll get to that in a minute. Okay, but the transition metals, they're also sometimes called the d block. Okay, so the d block right here, I guess I could be actually writing these out. I don't think you're going to be able to see this one yet. You're not. And I kept writing it anyway. And I'm writing over here anyway. Okay, so S block, D block, P block so far. So these, their electron configurations are going to end with D, right? Okay, so if you look at something like titanium, number 22, its electron configuration, let me erase some of these others here. So titanium's electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Okay, that's the end of its electron configuration. Let's make sure I did that right. 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 22. Okay. If you ever want to double check your electron configurations, one way to do that would be to add up all of the numbers for your superscripts here. And if that needs to add up to the total number of electrons that you have in that element. Okay.
What if one of them, like, S with 1? Is it different?
No, it would still add up to the correct amount.
Okay.
Yeah. So even with the exceptions, with like the chromium, there was one like that on the quiz. Yes, there was an exception. But you still could count the total number of electrons, and it would give you the right answer. Okay, so that's the D block. The last one down here. Any ideas what this bottom one would be? This is going to be the F block, right? Because its electron configurations are going to end in F. Now, I purposely have not given you any elements in the F block to write the electron configurations for. I'm not going to have you do that, okay? Because that just gets really complicated, all right? But you're just going to have to trust me here. These down here, their electron configurations will end with their last electrons going into an F orbital, okay? So that's why we call these the F blocks. So you've got those 4 blocks. That's one way to classify or categorize the elements on the periodic table, okay? And that's just based on where their last electrons, what orbital their last electrons are going into. Everybody okay with that? Everybody have that labeled on your periodic table because you're going to need that to study for the test on Monday, okay? And for the final. All right. So then it says besides those 4 blocks, there's another way of classifying elements. So let me erase this, and then we'll go back to the notes for a second. And then we're going to come back here, and I'm going to have you label a couple other things on your blank periodic table. Okay. We can classify them based on metals, nonmetals, or metalloids. Okay? Which, that's already on there for you, isn't it? Okay. So those are the 3 other classifications we can give to an element. So I could ask you, is it in the S block? Is it in the P block? Is it in the D block? Is it in the F block? Or I could ask you, is this element a metal, nonmetal, or a metalloid? Okay? And those are 2 different classification systems that you can use for elements. And the following slide shows where each group is found. Now, you may not be able to see, you may not be able to read this from where you are, but I'll kind of circle this for you. So the metals. Really, the key to this whole thing is this stair step right here, these purple elements. Now, on my periodic table, they're yellow, okay? You guys see that? You got the stair step line there, okay? So it's fairly easy to know where everything is, okay? Basically everything, well, okay, I should include these down here because these are technically considered metals as well. Everything to the left of that stair step line That's the metals. And I do want you to label that on your blank periodic table, okay? I know, there's a lot of stuff there. You're just going to have to figure out your system for keeping this all straight, okay? Yeah, the boxes are going to be blank. You're not going to fill in. So you can write directly over the boxes, okay? That's fine. If you want to write M in all of the metal boxes, that's a lot of M's to write. This is just your way to study for this, so I don't care how you label it as long as you understand it, right? So just come up with your system for labeling this, okay? But those are all the metals. Now, hydrogen's weird, okay? I made hydrogen green on my periodic table, and they made theirs orange because they're technically classifying hydrogen as a non-metal. Okay, it can sometimes act like a metal, sometimes act like a non-metal, so I just made it green. I made it different than every other color on my periodic table. It can act like a metal sometimes. Yeah, it just, in the sense that it tends to lose an electron when it's in a chemical reaction. So it's just kind of weird. Yeah. Why does yours go to 118? Well, so does mine, right? The one down here, they just haven't filled in the ones that. Yeah. Well, no. I mean, see, you don't have to worry about those down at the bottom, okay? The 118 stuff. You're never going to have to classify those. Okay. 113 to 118, and the reason you don't have to worry about it is they technically have not been proven to exist yet. So if you want to just scratch those out, that's fine. 113, the ones that are white on my periodic table over here, 113 to 118. What has happened with those is someone in a lab somewhere in the world has said, hey, we made element 113, okay? But it has not been, the experiment has not been repeated yet. It hasn't been proven that they actually did it. So once it's verified, then they'll give that element a name. Okay, right now it just has a placeholder name until it's discovered. I don't know what to call hydrogen. I'm not going to ask you what is hydrogen, okay? I'm just going to ask you about the stuff to the left of the stair-step line, okay? And then you're going to tell me, oh, those are metals, okay? Or I might ask you about iron. What is iron, right? Well, iron's to the left of that stair-step line, so it's a metal, okay? That's how this works. It's pretty simple. Everything that's on the stair-step line, everything in purple here, okay? Or on my periodic table, I guess it's in yellow, okay? Those are called the metalloids, or the semi-metals, okay? They kind of act like metals. They kind of act like non-metals. Okay, those are the metalloids. I usually call them metalloids, but you can call them semi-metals too. These are some of your most important semiconductors. Now, when I say semiconductor, what am I talking about? What does that bring to your mind, maybe? Kind of brings like electricity to your mind, maybe computer stuff, right? Computer chips. Silicon is what we use for our computer chips, okay? Because it's a semiconductor. And you can use the properties of silicon to actually conduct electricity at certain times, not conduct electricity at other times, and make a one-directional current. So it's really useful as far as computer chips. So that's what's used for computer chips. So that's the metalloids, okay? And then on the right side over here, everything that's in orange here, everything that's in blue on my periodic table, what is that going to be? Non-metals, okay? Now, I want you to notice something. No, actually, never mind. We're going to talk about the properties of these things, so we don't have to worry about that right now, okay? So you've got your metals, your metalloids, and your non-metals. That's another way that you can... I don't know. Yeah, MD is fine, or you could say S/M, semi-metals, right? I don't... All the ones in yellow on my periodic table, all the ones that are in purple up here are the metalloids. Okay? So That's the basic idea. Those are the two major ways to classify the elements on the periodic table. They belong to the S block, the D block, the P block, or the F block. And then you can also ask, are they metals, nonmetals, or metalloids? Okay? So as far as filling out the notes on this part, you've got the zigzag or staircase line that divides the table. Okay? The metals are on the left in blue. The nonmetals are on the right in orange. Oops, what happened? Oh, okay, showing arrows here. I did big circles. And notice the F block elements are also considered metals. They're also in blue, or on my periodic table, they're tan or whatever color that the metals are. Okay? So you would count those elements also as metals. And then the metalloids are the ones that are in purple. Okay, metalloids are semi-metals. The one important exception here, notice you've actually got this dark line right here that kind of divides the periodic table. Do you guys see that? Okay. Most things that are on either side of that line are considered semi-metals, okay? But aluminum is not. Aluminum is actually considered a metal. So you just need to know aluminum is a metal. But I think we know that, don't we? I mean, aluminum acts like a metal. It bends, doesn't break, conducts electricity. It does all the things that a metal does, okay? So, oh, you messed up on your stair-step line? Yeah, it's a little tricky, okay? You've actually got to go, you got to start it below boron. Yeah, sorry about that. I should have pointed that out before you started drawing. Yes. Yeah. It's the same. Yeah, and see, the thing is I didn't even draw my stair-step line. I just put in yellow the elements that were semi-metals. So not a huge deal, honestly. As long as you remember the ones that I have up here, the yellow divides the left from the right, okay? Because you're not going to be looking at that when you're taking your test anyway. That's just to help you study. You're going to be looking at mine, okay? All right, so that's the metals, metalloids, nonmetals. And we talked about the assumption, or the exception. Aluminum is more metallic than not, okay? Okay, so let's talk a little bit more about the properties of each of these things. So metals. What do you think? Tell me some properties of metals without looking at your sheet, okay? There are some words on there that might trigger your memory. But when you think of metals, what do you think of?
They're hard, they're shiny.
Hard, shiny, good conductors of electricity. I heard another one. Malleable, which means they're bendable without breaking. Okay. Do we know what ductile means? That's why I said don't look at the notes quite yet. Any other ones you can think of? They're not always, right? Aluminum's not very dense. They're usually solids at room temperature. We can say that, right? Okay, so they actually give off their heat fairly easily. We could say that. You got another one? Okay, some of them are magnetic. Not all of them, but some of them are magnetic. What's that? A lot of them have a tendency to rust or oxidize is another name for that. They react with oxygen. Okay, so those are some good properties. We're actually not going to go into all of those properties, but now let's see the nonmetals. What are some properties of nonmetals? So look at the things that are in blue up on the periodic table. Okay, we've got carbon, nitrogen, oxygen, fluorine, all the noble gases, phosphorus, sulfur, chlorine. Is there anything you can say that those kind of have in common? You're probably less familiar with the properties of those, I would guess. A lot of them are gases. Now, I don't know if we've talked about this on my periodic table. I think maybe we have once. But there's a way you can tell on my periodic table. The ones that are underlined on my periodic table, you guys see the underlined ones over there? Those are the ones that are gases at room temperature. Okay, hydrogen is a gas at room temperature. Yes. In fact, hydrogen, you guys have heard of the Hindenburg, right? It's the lightest gas in the universe, okay? So when people were first starting to make balloons, the thought was, well, let's fill them with the lightest gas and they'll float better, right? Well, the problem with hydrogen is, yes, it is the lightest gas. It's also very explosive. So there was a spark on the Hindenburg and the whole thing blew up, right? So then everyone was like, okay, let's use helium, the second lightest gas, because helium doesn't explode. It's completely non-reactive, right? So that's why you fill your party balloons now with helium, so that the whole birthday party doesn't explode, because that would really put a damper on things, I think. Unless, I don't know, I guess I could see that like at a little 5-year-old boy's birthday party. That was awesome! There's exploding balloons everywhere, you know? That could be kind of fun, but we don't do that for safety reasons, all right? So, yes, hydrogen is a gas. Now, the other thing that I was going to say here is the things that are in italics on my periodic table are liquids at room temperature. You're going to have trouble finding the ones that are italicized because there are only 2. Okay? Bromine is one, Br, number 35, and mercury, Hg, is the other one. The only liquid metal. Okay? So, and I say the only liquid metal, it's the only liquid metal at room temperature, right? You can liquefy any of the metals if you get them hot enough. So it's very rare for an element to be a liquid at room temperature, okay? And then the rest of them, if they're not underlined and they're not italicized, then they're solids at room temperature, okay? So most of the stuff on the periodic table is a solid at room temperature. All right. And what the heck is a metalloid? All right, so here's the metals. Let's talk about the properties of metals. They are lustrous. That's the technical term for shiny. Okay. They are malleable. That goes in one of your blanks. Okay. And what did we say malleable means? You can bend it without breaking it. Okay. If something shatters when you hit it, that is not malleable. So glass is not malleable, right? You hit glass, it shatters. But you hit, okay, yeah, certain types of glass. Fiberglass is a little bit malleable. Although you bend fiberglass too far, it'll break too. But a metal, you can hit it with a hammer, and it tends to bend or dent in, not break. Ductile. What does ductile mean? Probably don't know that one. Ductile is sort of related to malleable. It means that you can pull it into a wire. Okay, you heat it up a little bit, you can actually pull it out into a wire without it breaking. So you can make it into a wire. Now, why is that useful? We can make wire out of metals. Yeah, because metals conduct electricity, so we can make miles and miles and miles and miles of copper wire that conducts electricity, and we can have electricity for our houses, okay? They're also good conductors of heat and electricity, okay? All right, did we get all that written down already? Okay, so that's the metals. Mostly solids at room temperature. Now, we already talked about that. The one exception is mercury, right? Mercury is a liquid at room temperature, but the rest of them are solids. Everything else to the left of the periodic table is just, it's not underlined, it's not italicized. Okay, so that's the metals. And we talked about the one exception, which is mercury. Okay, so you can write down Hg. Hg is the symbol for mercury. It's a liquid at room temperature. Yeah. And it's also very poisonous for your brain, so don't touch mercury. Mercury is kind of fun. Actually, maybe in a minute I'll show you some mercury. Show you, not let you touch it or ingest it in any way. That would be bad. I've got it in a bottle. Oh yeah, we've got lots of stuff back there that's probably not very good for you. Okay, non-metals are basically the opposite of metals, all right? So whatever we said about metals, it's going to be the opposite. They're dull, okay? So they're not shiny. They don't reflect light. They're just dull, okay? They are brittle, which means you hit them and they crumble or they break, okay? A lot of you are writing with a non-metal right now. Do you know what your pencil lead is made of? It's not lead. It's graphite. And what is graphite? Do we know? What element? There's one element that makes up graphite. Not magnesium. It's actually not a metal, right? Pick one of the non-metals. Not chlorine, but you're getting close as far as the letters you're using. Carbon, okay? Graphite is pure carbon, okay? So the reason that your pencil writes so well is because it's brittle. When you move your carbon across the page, it breaks and it sticks to the page. Okay, if you're using a pen, it's different, but if you're using a pencil, that's how it works, okay? So non-metals tend to be brittle. They tend to break fairly easily rather than bending like the metals do, okay? They're also non-conductors. That's not always true, but as a general rule, that's true. Now, it's funny, the example I just gave you for brittle, the graphite, that's actually an exception to the rule. Graphite does conduct electricity, okay? So,
Have you ever done that?
where you electrolyze water, yeah. You can actually split water with a pencil. And a 9-volt battery. You need at least a 9-volt battery. But you can hook a 9-volt battery to a pencil that's sharpened on both ends, hook a couple wires to it, put them in the water, and they will actually split the water molecules, and you can see bubbles forming. That's the hydrogen and the oxygen bubbles forming. Maybe I could set that up at the beginning of next week while you guys are reviewing for the final. That'd be fun. What's that?
If you make it into light, you can make electricity that's
Really?
really, really hot.
Huh. I've never done that one before. That's interesting. Okay, so, but for the, I just talked about the exception for a long time, but the general rule with non-metals is that they don't conduct electricity, okay? So sulfur, not a very good conductor of electricity, okay? Do you guys know what sulfur is? What it looks like? What it smells like? Any of you been to Yellowstone before? Okay. Yeah, Yellowstone doesn't smell so good. Yeah, there are, well, yeah, there are geysers. There's a lot of under-the-surface heat activity going on that heats these hot springs and causes these geysers to shoot up. There's a lot of sulfur in there, too, so it smells bad. Okay, some are solid. A lot of them are gases, and then bromine's the liquid. Okay? So you do have some solids: carbon, phosphorus, sulfur. Well, this periodic table is always there for you anytime you're taking a test. So no, you don't have to memorize which ones are solids or liquids because it's up there. Right? Okay, underlined is gas, italicized is liquid, and then everything else is a solid. Okay? There's only two that are italicized. I feel like I'm in Groundhog Day right now. I'm saying the same thing over and over and over again. Okay, bromine and mercury, Br and Hg, are the only two that are italicized. Okay? You can't tell? Yeah. Okay, so that's the nonmetals. Now the metalloids, very quickly here. Silicon, again, is a very important metalloid. I guess also arsenic if you're looking to, you know, off someone. Don't do that. What's that? What do they actually use it for? I don't know that there's a lot of other uses. Yeah, other than to kill someone with it. It's very, very poisonous. Okay, so metalloids are semi-metals. That means they kind of act like metals, they kind of act like non-metals, okay? So they have characteristics of both. They are shiny most of the time, but they're also usually fairly brittle, okay? So silicon, you can see, it does look shiny when you look at it, okay? But if you hit it, it's not going to bend, it's going to break, okay? So it's kind of almost half and half, okay? And they are semiconductors. What that means is, under certain conditions, they will conduct electricity. Now, usually what you have to do is you have to heat them up a little bit in order for them to conduct electricity. You have to give them energy in some way, okay? Metals will conduct electricity just no matter what, okay? But the semi-metals, or the metalloids, you have to give them a little bit of a push before they will actually conduct electricity, okay? And that's actually a very useful thing when you're building a computer chip, to have something that conducts electricity sometimes, but not at other times. And our most important semiconductor would be, I keep talking about it, silicon, right? Silicon, not silicone. There's a difference. Silicone is made of silicon, but it's not just silicon. Oops, that's all. Okay, so that's it. As far as the periodic table, that's all we're really going to talk about for now. So what I want you to know is those categories, the S, P, D, and F, and I want you to know the classifications of metal, non-metal, metalloid, and some of the properties. Okay? There will not be a quiz tomorrow because I'm just going to let you spend the rest of the time today and the time tomorrow basically just getting ready for the test on Monday. Okay? Listen up. One important thing very quickly. If we have a snow day tomorrow, I don't think that we're probably going to. I'm just trying to plan ahead, okay? If that happens, the test is still on Monday, okay? Because you have the study guides for the test. I'm giving you the rest of the hour today and all of tomorrow to study for it, so you just have to study at home if we don't have school tomorrow. If we have a snow day on a final day, then I think we take them when we get back from Christmas break. So I really hope that doesn't happen.
I was. Oh, it is.